A geometric series has first term a and common ratio r. Prove that the sum of the first n terms is given by Sn equals a times bracket 1 minus r to the n, all divided by 1 minus r. The sum of the first two terms of a geometric series is 25.2. The sum to infinity of the series is 30. Given that the common ratio is positive, find the common ratio and first term of this geometric series. So I've got the question here in summary form as usual. So let's have a little go at this. The first part A is a standard bit of bookwork here. So we've got the sum of the first n terms of a geometric series, so we can write that out long-windedly as ar squared, and then it's ar to the n minus 1, and then the last term, the nth term, ar to the n minus 1 is the nth term, isn't it? 'Cause it's always 1 power less. So that's the sum of the first n terms. There we go. So now if we times by r, we can label that 1. Now multiply 1 by r gives, so we're going to multiply by r, so we get rsn is equal to times this by r, times this by r, plus dot dot dot, and then we're going to have the preceding term times by r will be ar to the n minus 1, which will be that term, but that term times r will be ar to the n, one term. Okay, so because we've got 1 minus r, I'm going to take 1 minus 2. 1 minus 2 gives, so let's see what we get. On the left, Sn minus rsn. Sn minus rsn on the left is equal to, and when we take them away, the ar and the ar will cancel. We're just left with the a, so these terms will cancel, so to speak, and so too will this. All these diagonal pairs can be paired off, because they one take the other. And all the way down to here, and this will cancel with the one before it, but it will leave, so it's a, all that's left is take away ar to the n. And that's, let's see what we get then on the next line. We can simplify it now. So here we've got an Sn as common. There's a 1 here, minus an r there, is equal to a, common, 1 here, minus r to the n. So finally now we can write Sn is equal to a, 1 minus r to the n, all over 1 minus r. Okay, good. So that's a. Part B now. The sum of the first two terms is 25.2. So part B. So a plus ar is the first two terms, is 25.2. The sum to infinity is 30. So S infinity is equal to a over 1 minus r. That's equal to 30. So that tells us that a is equal to 30 1 minus r's. Just move the 1 minus r up to the top. This is number 1. This is number 2. And we know that r is positive. So let's substitute 2 in 1 then for a and get an equation in r. So sub 2 in 1 gives. So a will be, a is common, so we can write a 1 plus r, can't we? So that's a, 31 minus r, that's the a is common, then a bracket, and this will be in our mind's eye, a times 1 plus r. And that will equal 25.2. So straight away then, we can see that this bracket here will be 1 minus r squared. And then we can also move the 30 from times on one side to divide on the other. So now that we can read off r squared, move the r squared over here, and move this fraction over to be with the 1. So it will equal, reading from right to left, 1 minus 25.2 over 30. And of course 25.2 is 4.8. 30 over 30, take away 25.2 is 4.8. So r squared then will equal 4.8 over 30, which equals 48 over 300. And we can square root that, if we wish. I'm just going to divide it down, I think. 16 threes, yeah, 16 threes, so that's 16 over 100. Because to cancel by 3 top and bottom. And then we can cancel by 4 top and bottom, 4 over 25. Square root both sides then. R square rooted is equal to this square rooted. We're not worried about the negative because R is positive, it just gives R as 2/5 as the common ratio. And now we can find out A. By 2, A is equal to 30, 1 minus 2/5, which is 3/5, which is 90 over 5. Clap it in the calculator if we need to, and that comes out at 18. So A is 18, the first term, and the common ratio is 2/5.